So figure 2 shows a sketch of part of the curve with the equation y equals x multiplied by x plus 2 multiplied by x minus 4. The region R1 shown shaded in figure 2, so that's this region here, is bound by the curve and the negative x-axis. And part A says we need to show that the exact area of R1 is 20 over 3, and that's for 4 marks. So the way to find the area under a curve, which is what R1 is, it's an area that's under a curve, we need to integrate. And what we've got the equation of the curve here. We need to know the limits of integration. So when you integrate between A and B. However, we need to know what those values are. So in the case of finding the area R1 here, we need to know this point and this point here. So we need to try and work out what the roots of this curve are, or where it crosses the x-axis. So to do that, we're going to use the equation of the curve they gave us here. And it's actually really useful because they've already given it to us in factorized form. So it's much easier to work out what the roots are, or the x-intercepts. So to work them out, what we need to do is set y equal to 0, because at all these points along here, y is at 0. So if we just set y equal to 0, we can then solve for x. So if we do that up here, we've got the 0 equals x multiplied by x plus 2 multiplied by x minus 4. Here we've got the x equals 0. We've got the x plus 2 equals 0. Or x minus 4 equals 0. And making x a subject in all of those, we get these 3 roots. So we've got x equals 0, x equals minus 2, and x equals 4. So we can work out which ones those are on the graph. So this one is x equals 0. This, because it's on the negative side, must be x equals minus 2. And this is the one that's left over, so that's x equals 4. Now we know to work out the area of R1, we're going to integrate between minus 2 and 0. Now the last thing we're going to do before carrying out the integration is see what form we've got the equation of the curve in. Because at the minute it's in factorized form, which was helpful for what we just did, so like working out the roots. However, it's not very helpful for integration. It's much easier if it's sort of, the brackets are expanded. So we're going to do that now, quickly. So we're going to expand the brackets. To do that here, we've got y equals. And if I expand these two brackets first, we're going to have x squared. And then we've got minus 4x plus 2x. So it's minus 2x. And then we get minus 8 there. And then I'm just going to multiply the x through into the bracket. So we're going to have x power of 3 minus 2x squared minus 8x. So now I'm going to carry out the integration to find the area of R1. So we're going to integrate x power of 3 minus 2x squared minus 8x with respect to x. And this is going to be between minus 2 and 0. So doing that here, I'm going to put some square brackets. Now, we're going to integrate each term individually. So starting with the first one, we're going to add 1 to the power. So we get 4 and then divide by it. So we get a quarter, x to the power of 4. And then for the next one, again, we're going to add 1 to the power. So we get 3 and divide by it. So we get minus 2 over 3, x power of 3. And again for the last one, so we're going to divide by 2. So we get minus 4 x squared, and that's between minus 2 and 0. Great, so we're now going to evaluate this up here. So we're first going to sub in x equals 0. We can see we've got an x in each of these 3 terms, so it would just go to 0. So when we sub x equals 0 in, actually just goes to 0. And then we're going to take away, and then we're going to sub in x equals minus 2. So doing that, we get a quarter, minus 2 to the power of 4, minus 2 over 3, minus 2 to the power of 3, minus 4, minus 2 squared. And one thing to note is that these brackets are really important because we're taking away all of this. So it's really important to remember the brackets. Right, so now if we evaluate this, so I'm just going to put all of this into the calculator, we're going to see what we get. So we have minus multiplied by, and if you put that into the calculator, you get out minus 20 over 3. And that's actually great because the last thing we're going to do is we're going to multiply the negative into the bracket, which gives us positive 20 over 3 as needed. So that's fantastic. We completed part A. So we're just going to see where we get our 4 marks from. So we get the first mark here. So expanding out the brackets into a form which is more appropriate for integration. We get another mark for this line down here. So working out that what we need to do is integrate between -2 and 0 and integrating the curve. We get another mark for actually carrying out the integration. So the key part is everything inside the bracket here, so we've correctly integrated. And then we get the final mark for all of the rest of the working here. And the key part is this here, so where we've subbed in -2 and written it all out like this. We can't just skip to the answer because it's a show that question. So we need to make sure that we're showing each part of our working line by line to get all the marks. The region R2, also shown shaded in figure 2, is bound by the curve, the positive x-axis, and the line with the equation x equals b. So that's this region here in figure 2, and this is the line here, x equals b. B is a positive constant between 0 and 4. Given that the area of R1 is equal to the area of R2, we need to verify that b satisfies the following equation. So b plus 2 squared multiplied by 3b squared minus 20b plus 20 equals 0. And again, this part is for 4 marks. So like in the previous part, we're working with areas under curves. So again, we're going to be dealing with integration. So setting up an integral for finding out the area of R2, we need to integrate between 0 and b to get the area of R2. So if we do that, if we integrate between 0 and b, and then it's the same curve as before, and actually in the previous part here, we expanded out the brackets to get the equation of the curve in this form, because it's just easier to integrate compared to the factorised form of the question. So I'm going to use the expanded form here. So we're going to integrate x power 3 minus 2x squared minus 8x with respect to x. Key part here is that the area of R1 is equal to the area of R2. And because we know the area of R1 is 20 over 3, we could be tempted to put here, okay, so that's going to equal 20 over 3. However, we need to be careful because that's not actually going to be the case. R1 is above the x-axis, so when we find the area under the curve, the integral evaluates to be positive. However, R2, whilst the physical area is 20 over 3, because it's below the x-axis, it's actually going to be negative. So this will evaluate to minus 20 over 3. Fantastic. So now we've set this up, we can start working with it. So I'm going to carry out the integration, and this is actually exactly the same as in the previous part. So we get a quarter x power 4 minus 2 over 3 x power 3 minus 4x squared, and that's between 0 and b, and again that equals minus 20 over 3. And evaluating this, we're going to sub x equals b and then take away subbing in x equals 0. So doing that, we'll get a quarter b to the power 4 minus 2 over 3 b to the power 3 minus 4b squared. And actually, we can see there's an x in each of these individual terms, which means when we sub in x equals 0, it's just going to go to 0. So I can just write minus 0. And that equals minus 20 over 3. And here we've just written that in a bit of a more succinct form. One thing I noticed here is that we've got quite a lot of fractions. And I don't really like that because that's quite hard to work with. So we're going to try and get rid of that. So first thing I'm going to do is I'm going to times both sides by 3. And that's going to get rid of these fractions here. Okay, so that's 3b to the power of 4 over 4. So for the next term, the 3's cancel, so we're just left with minus 2b to the power of 3. And then we get minus 4 times by 3, so minus 12b squared. And then again, the 3's cancel. So we're going to get minus 20. Okay, so lastly, we've got this fraction here. So if I multiply both sides of the equation by 4, the 4 is going to cancel, so we get 3b to the power of 4, minus 8b to the power of 3. 4 times minus 12, we get minus 48b squared, and that equals minus 80. And lastly, just adding 80 to both sides to set the equation equal to 0. Fantastic. Now looking back up at the question, it says that we need to verify that b satisfies this equation here. And now to do that, we could start working with this equation here, trying to factorise it down until we reach the form of the equation in part b. However, that looks quite difficult. So instead, what I'm going to try doing is expanding out this equation here in part b and seeing what we get. And if this matches what we've got here, then we sort of met in the middle and we verify that b satisfies the equation. I just want to point out the reason we can do this is that it says verifying the question. So this is a way that we can verify it. We can sort of work backwards and meet in the middle. However, if it didn't say verify and it said show that, it would be better to work with this equation and sort of factorise it out till we get to the desired answer. But the fact that it says verify in this question means I'm going to use this method of working backwards. So expanding the brackets, we get b plus 2 squared multiplied by 3b squared minus 20b plus 20 equals 0. So starting with this bracket here, we'll get b squared plus 4b plus 4 multiplied by 3b squared minus 20b plus 20 equals 0. Now to multiply this out, I'm going to do each term individually. So I'm going to multiply the b squared by each of the terms in this bracket, and these terms, and then these terms. So doing that, starting off with the b squared, we'll get 3b to the power of 4 minus 20b to the power of 3 plus 20b squared. And moving on to the 4b now, we'll get 12b to the power of 3 minus 80b squared plus 80b. And lastly, we'll get 12b squared minus 80b plus 80 equals 0. Great, the first thing that jumps out to me is we can see here, so these 80b's cancel. And then the rest, what I'm going to do is just going to group like terms. So get 3b to the power of 4, and then grouping them by their powers, we get minus 8b to the power of 3 minus 48b squared. And we're left with the constant in the end plus 80 equals 0. And that's fantastic because these equations exactly match, which means we verified that b satisfies the equation. So I'm just going to write something down here to succinctly explain that. Since equations a and b are identical, we have verified that b satisfies the equation. So looking to see where we'll get the marks, we get our first mark for this line here. Then we get the second mark for deducing this here, so going through these steps to write it in this form. And then to get the rest of the marks, you could take either approach. So you could either factorise this down until you get to this equation, or taking the approach that we did, we can successfully expand this equation here and then state that we verified it because both of the equations are identical. So lastly, we're going to take a look at part C. So the roots of the equation 3b squared minus 20b plus 20 equals 0 are 1.225 and 5.442 to 3 decimal places. The value of b is therefore 1.225. And in part C, it says we need to explain with the aid of a diagram the significance of the root 5.442. And this is for 2 marks. Well, the first thing to notice that this is actually this here. So these are the solutions to this bracket here. And we've been told in the question that this point, so we've got x equals 1.225. So quickly thinking back to what we did in the previous part, you've got that if you integrate between 0 and b, I'm just going to put y here, but we're integrating the curve with respect to x, and we get minus 20 over 3. And what they've given us here is what the values for b actually are. However, we've got 2 values of b, so we've got 0 and 1.225 of y with respect to x is minus 20 over 3. However, we've also got the integration between 0 and 5.442 with respect to x is also minus 20 over 3. And we want to have a think about why that could be. So this one here makes sense because we know that the area of R2 is 20 over 3. So this one makes sense. However, we've got a second value for b that we also get the same result. And the reason for this is when we're integrating, any areas that are above the x-axis will be positive, any areas below the x-axis will be negative. So I'm going to roughly sketch on where 5.442 is. So that will be somewhere along here, so somewhere past this point, because we know this point is x equals 4. So this is x equals 5.442. So when we're integrating between 0 and 5.442, we've actually got a positive area here and a negative area here. And then when you combine them together, we turn out with minus 20 over 3. So I'm just going to shade this area to make it clearer. So we've got this yellow area here. So when we're integrating, because this area is positive and this area is negative, the net area is also minus 20 over 3. So to get the marks, we need to sort of write this succinctly. The net area between 0 and 5.442 is minus 20 over 3. So brilliant. So now this statement also makes sense to us. Now I'm quickly looking to see where we get the 2 marks from. We get the first mark for drawing a sketch of the curve and then drawing a vertical line to the right of x equals 4. So that's what we've done here, so we get a mark for that. And I just copied the diagram across, but in the exam you could just draw a really rough sketch of the curve to get the marks. And then we get the second mark for a correct statement like this. So saying that the net area between 0 and 5.442 is minus 20/3. There are also other possible answers you could give for why x equals 5.442 is significant. For example, that between x equals minus 2 and x equals 5.442, then the area above the x-axis is equal to the area below the x-axis. And there are some other statements like that you could give. However, this is the one that I chose.